Okay. Um, who am I? My name is Victor Sura. I'm a software engineer at Cafion. I've been working on a product called Advanced Installer for over a decade now. We're working on improving our repackaging capabilities in our product, helping our customers migrate their legacy Windows applications to the modern application model and the Windows Store. And recently, I've been involved in a hobby project. Some of you might know it, Clang Power Tools, trying to bring some of the Clang Tidy goodness to Visual Studio. So this is part 1 of N for this talk, because I have lots of ideas on developing this further, and I'm going to receive lots of feedback going along. This is the first version of this talk. And depending on how well it goes, N might be greater than 1. So why string view? Why are we talking about strings? Have you really exhausted all the cool topics regarding template metaprogramming? Well, wouldn't it be nice if we had the standard C++ type for representing strings? Well, we kind of do, standard string. It says there, right in there in the name. Wouldn't it be nice if we could use that standard type throughout our whole application? Well, we can. If we're developing a console application or a service, but as soon as we need to interact with GUIs or system frameworks or modern operating system APIs, we soon run into other types of strings that we need to interact with. So depending on your platform, this might be ATL C string or MFC C string. If you're working with WX widgets, WX string, or if you're using Qt Q string, why not const char star for C-style APIs, Foley FB string, and what the heck, WDF string. That comes from WebKit, by the way. So in dealing with these types of strings, depending which ones might be your favorite or the one you need to use, all kinds of questions arise regarding its usage, implementation, and semantics. We might be wondering, does it support small string optimization? Does it implement copy on write? Some of those string types implement copy on write. Is my C++ string type thread safe? Does it support char traits? Does it support a custom allocator? Some people care about that. Does it play nice with string literals? Can I use it in a const_expr environment? Does it support encodings, Unicode, system locales? These are just some of the questions that we need to ask ourselves when dealing with a non-standard string type, and especially when interacting between two different string types. C++ superstring to the rescue. I'm pretty sure that S stands for string. I'm not kidding. There's a real project on GitHub called Superstring. I just discovered that. And has some interesting claims regarding performance. Apparently, it uses a rope data structure and some game theory techniques. I don't know what that is, but try it out if you're curious. So, going back to a more serious note, so we end up with a, let's call it X string, type of C++ string that we need to interact with. Let's call that our platform string. We have our standard string. We have some APIs that are C-like and deal in pointers to characters. We have to deal with string literals. And, okay, it's manageable. We have basically two C++ string types. We'll constrain ourselves to using standard string for all platform-independent code. We'll use that platform string for interacting with the operating system or the frameworks that we need to use. And we call that glue code. We'll end up with some funny-looking functions that deal with two types of strings in the same context. And OK, we'll have some unnecessary copying going around, but hey, that's just glue code, right? Doesn't matter. Until our project grows, and we start to accumulate a pool of string algorithms that we like to use. Algorithms that extend the provided STL algorithms for dealing with containers and strings especially. So then we have to ask ourselves, do we limit those algorithmic goodies that we develop over time just to be used with standard string and not being able to use them in, let's say, UI code or visual controllers? Or do we fall back to a common denominator and design our API interface to be const character pointer? I don't like that. Is C++ 17 string view the answer to all our questions? Well, let's find out together. I'd like to get a feel for the room. It's a little bit late. I think a little stretching is in order. How many of you are on C++ 9803? A few hands. Good, good. How about 11? OK. 14? Wow, even better. How about 17? Nah, now I've lost you. OK. So no C++ 17, no problem. I was anticipating that. There are alternatives that I would just like to review. There's Abseil string view. That's one of the newest. That comes from Google. An older one, string piece, again from Google. String ref from LLVM. Boost string ref. And Foley range, and others. These are just some of the most prominent ones I wanted to mention. So this is not exactly a new concept. It's just new in the standard. And it's new in our mind. And for those of us who haven't interacted with one of the older ones, it's just something that we need to think about and be aware of. Special mention to Abseil string view because of their excellent documentation on this regard. They do have a website for the Abseil project. How many of you have heard of the Abseil project? Has been launched recently at CPPCon last year. OK, a few hands. So it's an open source project by Google. They decided to open source some of their core platform libraries and algorithmic goodies for others to use, and it's available on GitHub. What I like about it is that it has pretty good documentation. Has rationale explaining the string view. Abseil string view tries to mimic the API of the standard string view. Has rationale, examples, gotchas, documentation. Abseil is not meant to be a competitor to the standard library, and many utilities serve to enrich the experience for people that use the standard library. Same way as Boost does, for example, and provides alternatives for people that are stuck with an older toolchain. For example, people like some of you that cannot use C++ 17 and can use something like Abseil string view with a almost matching interface in the meantime, and when you're ready to upgrade your toolchain, you can seamlessly switch to the standard string view. Details to be discovered. How many of you do remember Herb Sutter's Guru of the Week? Some of the older ones? OK. Cool. I very much enjoyed those. Well, the Abseil team has collected a bunch of their tips they're calling AppSale C++ tips of the week. And they're very similar in a sense to Herb's Guru of the Week series. And wouldn't you know it, the very first tip is about string views. I thought that was interesting. I collected some more links for you to explore later when you get the slides. I will get into some details, but I will not cover everything that's described in AppSale website. So coming back to standard world, to C++ 17 string view, I hope everybody knows cppreference.com and uses it as a reference documentation. It's very good. So the complex definition would be that basic string view is a template that describes an object to refer to a constant continuous sequence of char-like objects. Wow, that sounds so like a mouthful. So a typical implementation holds only two members, a pointer to a character and a size. And has almost the exact same interface as a constant string. So conceptually, it is meant as a replacement for a constant string reference. We'll see a bit more about that later. What string view offers, and we don't have in standard string, are two helpers for narrowing the view over the string that we're watching, remove prefix and suffix, which come pretty useful when parsing constants. So it's a lightweight string-like view into an array of characters. And it can be constructed from a pointer and a length, or from a null-terminated string. So its design goal, like many of the others presented before it, was to interoperate with standard string, and we're going to see some gotchas regarding that, and to avoid temporary string copies when using it, unnecessary copies. But that doesn't come for free. It comes with some usage complexity, as we'll see later. So why are we trying to avoid temporary strings? Well, they're not exactly small. They may allocate memory. Small string optimization mitigates some of these issues and avoiding going to the heap. We do some unnecessary copies. Yeah, we might have a string type that does copy on write and doesn't copy when it's not necessary. This is, by the way, now disallowed by the standard, for standard string at least. So string view basically doesn't manage its memory. It's just a view, a non-owning view into another string. And the lifetime should be managed by the caller. So why would we want to use a string view instead of a string? When would we want that? Let's see some of the situations. But first, we need to be aware of its structure, its anatomy. And most important things are its constructors and operators. So these are all string views constructors. And one special case would be the one that constructs from a pointer to a character, because that one is not exactly cheap, because it assumes an ultimating string, and it must calculate the length of the past string. And yeah, it's const_expr. This might happen at compile time, or it might not, depending on if the compiler can actually see that string at compile time. For example, for string literals, that's fine. One interesting bit is that standard string has been enriched with an operator to convert it to a string view. And it basically behaves as if returning a string view constructed from accessing the string data and its size. That would be a basic implementation. So as a summary of interoperability and conversions, a const_charAct automatically converts to a string via constructor that's not explicit. Okay, we knew that. Const_char star automatically converts to a standard string view via a non-explicit constructor. That's new. Standard string automatically converts to a string view via conversion operator. We just saw that. That's new. And we can construct a standard string from a string view via an explicit constructor. We'll see that one later. So, storing string views. We are used to storing strings, but storing string views. Well, the short answer would be don't do it. It's potentially risky. For example, if we're storing a vector of string views and we acquire one of them from a standard string, yeah, we don't have any compiler warning in doing this, but we do have a potential for a dangling reference to a non-existing string. So here's another example. If we're storing a standard map of strings, for example, we're counting the frequency of some keywords, and we want to look up such a keyword in the map by using a function parameter type of type string view. Does this work? Well, it doesn't compile. Why it doesn't compile? Because there's no conversion to standard string, and the add method on the map requires a const string reference. So there's no implicit conversion going on there. So this, I would say, is a fortunate case, because we can see the problems at compile time, not later. But what if we want to find, let's elaborate that example a little bit more. Excuse me. If you want to find the frequency for a given keyword, we can use a transparent comparator, because our stored key type in the map is of type standard string, but our argument for the find function, our keyword that we're looking for, is a string view. And because we don't have an exact match between the argument type and the key type, we cannot use a standard map without a transparent comparator. This is one of the reasons that we got transparent comparators in the standard. So this allows us to provide our own, or in this case, use a built-in one, standard less, which is a transparent, less without any template argument. And this transparent comparator allows us to compare the two types if they're convertible to each other, even though they're not the same type. So this uses operator less, as the name implies, for the standard function object less. And there is an operator less provided for string views. That's new in C++ 17. That's right in the box. So yes, this example does what we think it does. So I would like to think that my compiler will help me not make mistakes when using non-owning types. Well, let's see another example here. We have a sync class because we store the value that we're provided with, and we take that value by string view, and we're storing it as a string. And we decided to move it into the string, but that's optional. Well, does this compile? How many of you think it compiles? Okay, a few hands. Well, it does. So I got screwed by my compiler. And it compiles because of this nifty little thing. It's a constructor, a special constructor that's explicit but it's a template function, function template. And this one participates in overload resolution only if the provided T type is convertible to a basic string view, to a string view. If T is not convertible to a string view, it doesn't participate in overload resolution. So it cannot match anything. So this actually converts the given type to a string view and constructs the string. This is actually added in C++17 in standard string. So because of this little thing, when we pass a string view, we can construct a string from it when storing it. But this is potentially dangerous because that string view might be a view into a string that it's no longer viable, no longer alive. So we're storing a dangling reference, basically. So don't do this. And it's tough because our compiler will not help us in this case. So don't use a string view to initialize the standard string member. Never. Maybe if you're certain that by construction you know that that string view points to a string that is alive as long as the place we're storing it in, it's tricky. And if you know that you're ultimately going to store a string of characters into a standard string, don't try to mix and match and pass it along a call chain as either a string view or a string. Because this will lead to issues along the way. So try to avoid, if your destination is a string, pass it as a const string reference along the way. It's much more safe and simple to understand. So don't intermix them. So the compilers failed us. What about static analysis tools? Do they catch some of these things? I would hope so. How many of you have used Clang Tidy? Quite a few hands. Okay. I think it's time to plug the project I've been working on now. So if you want the Clang Tidy goodness and also Clang format in Windows World and in Visual Studio, there's a Visual Studio plugin called Clang Power Tools that you can use and leverage all the Clang Tidy magic in Visual Studio. And it's free and open source, by the way. So does Clang Tidy really help in this case? Well, with over 250 checks, I would surely hope that there is some check for that. Well, these are all the checks related to strings in Tidy, and I'm talking about LLVM 7 right now. And those are very nice. Some of them are very useful. I've got some interesting situations in my code using them. But there's nothing related to string views there. So that's greenfield territory there if you want to contribute. More on that later. So no check for string view. That's disappointing. What about string literals? I mentioned string literals earlier. Do they play nice with string view? I should hope so, because string view was designed with them in mind, having const expert constructors and everything. So we have a simple example here. A string view initialized, two string views initialized, one with a array of characters and one with a string view. Notice the raw string literal SV there that constructs a string view from a literal. So what does this print? Anyone? 3 and 3 and 8. 3 and 8. I heard 3 and 8. So I don't trust you, so I'm going to check. How many of you have heard of Compiler Explorer and have used it? Oh, pretty good chunk. Better than Clang Tidy, I might say. So this is the website for people that don't know. And it's an online tool that hosts a bunch of compilers and different versions of those compilers. Compiler from Visual Studio, GCC, Clang, and other compilers. So you can basically paste your code in there, and it compiles your code, and you can see the disassembly, and it's very nice. You can share those code snippets over. There's no privacy issues because the code snippets are not stored on the server. They're just encoded in the URL, so it's very nice for sharing. So let's see. I don't know if you can read that, but I'll increase the font. Is that better? And on the right, on the disassembly, yeah. Never mind all that assembly stuff. So because Compiler Explorer right now does not support running the programs, we can basically check the sizes by using the return value and see what is stored in the AEX register. So if we want to see this better, I think we can do this. Oh, look at that, 3. So the first part was correct, and the second one, 8. Cool. So it was determined that I wanted some string view in my life. And I was sure that I was going to change everything in the libraries, in the source code, on the product I work on. And then I made an interesting decision. I decided to go and watch this talk at CPPCon last year. C++ templates revisited by Nicolae Iosoutis. And I saw some words like string view is a nightmare. Those are exact quotes. String view is worse than a string reference. String view is semantically a string reference, but conceptually a value type. Okay. So I was a bit scared, to say the least. And if we analyze just one of Nico's examples, we have a function template that returns a double. Pretty straightforward. We have somewhere an operator that can add 2 string views and returns a string, because we need to return a string, because we're concatenating 2 strings. We have an input string view, and we calculate the result, the concatenation. So we have a runtime error here, because, so who can tell me why we have a runtime error here? Yeah, but we have there the type of what is the type of error of R here? The type of R. So the type of R is a string view. Well, we can fix that, and Nicolae Iosoutis showed us how we can fix that. But the bottom line of his conclusion regarding string view was never assign to auto, and be aware that almost always auto idiom is broken because of string view. So we must be aware of that. This is a picture I actually took while in his talk, so just as proof. So an easier way to fix this is to use auto as a return type for the double function, and this way the return type R is now a standard string and is no longer a string view, so we're fine. But this is not something that's intuitive. It's not something that our compiler or static analysis tools can warn us about, so it's just something that we need to be aware of. Some of these issues are trying to be addressed and fixed. Not all of them. Some of these issues are described in this paper. And they might be fixed in the next revision of the standard. Smart people are working on it, but no guarantees. I've put a link up there if you want to read it. It explains the rationale and has very good examples and proposed solutions. So a few more months passed since that CPPCon talk. So then I attended Meeting C++ in Berlin, and then I got a more positive session. Of course, I couldn't resist going to it when I saw it in the program. String views everywhere, by Mark Mutz. So that was a reassuring talk. He actually mentioned Nico's talk, and he was much more positive on us as a C++ community being able to use string views. And there's a reason why he was more confident. It's because he implemented QStringView in Qt library for QStrings. So then I was happy after watching that talk. So I got more confident, and I thought to myself, yeah, I can do this. I will manage to use string views in the libraries in my project. And there are resources to help you. If you search around, you won't find many talks on string views, but you will find discussions and articles. And two very good articles by Jonathan Mueller. I put the links there. On string views accepting tap arrays, good or horrible pitfall. And guidelines for R-value references in APIs, where he mentions the case of dangling references when using string views as parameters. There's also Andrei's blog, Strings Competing Constructors, not especially focusing on string views, but useful when we think about all the automatic conversions going on and being aware of how constructors can bite us in some situations that are not obvious. Another interesting article by Arthur O'Dwyer, string view is a borrowed type. This has a catchy title, and I was immediately curious what he's referring to. So, what is a borrowed type? So, he shows a few simple examples where he argues that a string view successfully achieves the goal of being a replacement for a const string reference, but in replacing it in function parameters. But the problem is that we're dealing with a new kind of C++ type. We have our old friends value types, like structs or built-in types. We have our object types that have reference semantics, and we have another category of types, those that he calls borrowed types. And he clearly places string view in that category. It's not the first one, but it clearly is the most popular and mainstream of those. For example, he also mentions it tuple and reference wrapper. All those are infrequently used. So what is a borrowed type? So a borrowed type is a type that borrows references to existing objects. It lacks ownership. borrowed types are short-lived, usually, if used properly, anyway. They can do without an assignment operator, but as we saw, string view supports an assignment operator. They generally appear in function parameter lists. They generally cannot be stored in data structures or returned safely from functions because of lack of ownership. And string view, by that definition, is a borrowed type, with the exception that it does support assignment, but assignment has shallow semantics for string views. Of course, when we talk assignments, string views offers us a view into an immutable string. So, but nevertheless, the assignment is a shallow operation. Meanwhile, the comparison is a deep operation. So the string views might have to point to exactly the same contents. So borrowed types, as a conclusion, he says that borrowed types must appear only as function parameters or for loop control variables so that we constrain their scope and we can see exactly where they're referenced and their lifetimes. And he says we can make an exception for return types as long as, of course, for performance reasons. Why else would we want to do that? But we have to explicitly annotate those functions that could potentially return dangling references to strings. So, okay, I'm returning a string view here, and caller, part of the contract with the caller, be aware that when you use this, make sure the string view points to a string that's still valid after the function returns. And the result, as we saw earlier, must not be stored in a data structure. Instead, we can pass it along to another function as a formal parameter, or use it as a for loop control variable, just as before. So another article, a very interesting article that I put a link to, is by Marco Arena. It's an older article. I think it's before the standard actually came out, C++ 17, but it's a very good article, has very nice examples. And again, the title is irresistible. So I think, concluding, I think he said it best, string view odie tamo. String view, I loathe you and I need you, I want you. So take what you can get. It's a nifty, useful tool. It does allow to avoid lots of unnecessary copying. So it's attractive. It does offer this interoperability layer between interfacing two string types. So it's a good common denominator. It's a standard type, so it's appealing in that. But it does come with complexity in using it, and we have to be disciplined and follow some of the rules and idioms and be aware of the gotchas. And if we decide to use it in a dangerous or atypical scenario, we must properly document so and make that part of our function contracts so that the callers must be aware that we're returning potentially dangling references, just like we do with other reference types. In the end, I always like to conclude with the social part of interacting with people. If you're not always aware of this, I think John also mentioned it in his keynote this morning. Listen to CppCast. This is where I heard about lots of articles and blog posts regarding string views. They talk about new stuff, blog posts each and every week. They talk about conferences and sessions. So it's very good material to follow up on. And also, you can follow them on Twitter, so they usually share good content. Also, C++ Slack, join if you're not already in. There's lots of channels there. Yeah, there is considerable noise on some of those channels, but you can pick up good information and ask for help. When you cannot figure something out, you can usually ask, and people will jump in and help. And with that, if you have any questions, do ask. Thank you. I can go back to any of the slides if you want to.
Thank you for the talk. I have a question. What do you think why R-value reference overload for operator string view is not deleted in string?
Could you repeat that?
Yeah, why R-value reference overload for operator string view in string is not deleted?
It's not deleted?
Yeah, it's not deleted.
Yeah, it would
so
be,
it looks like it makes no sense to construct string view from R-value string.
Yeah,
right?
It would be nice. And yeah, I didn't design it myself, but in hindsight, I don't think I would have thought about that. So as with any design decision, mistakes will be made along the way. And it's easier to fix mistakes in software. We call that bug fix, and we just released a new version. It's much more difficult to fix mistakes in the standard. So yeah, that would have helped, but in hindsight, it's easy to point that now. But think about it, various flavors of string views were in use in several libraries, and I showed several of them. And still, so you would have expected that the community had the feel for it, and the people on the standards committee are smart people. They know what they're doing, and they're aware of the library efforts and implementations and experimentation going on in Boost and other libraries. And still, they miss some of the corner cases because of lack of real-world usage at scale. When you play around with toy examples, you don't always see all the problems. When the complexity of a project using string views grows, then problems become evident. So we're just gaining experience as we go. This was a learning experience for myself. So I was very enthusiastic when I heard about string view, and the more I learned about it, the more articles I read, the more I played with it, the talks I've seen, just a few, unfortunately, I was more scared. Yeah.
I wanted to point out a simple use case. We had it in our code base. We tried to delete basically the R-value constructor for our internal string view, let's say.
You can do that.
Yeah, but it broke a lot of some legitimate code when you just accept a function accepts a string view, and you want to pass there a result of another function that outputs a string view. So you naturally want that string view to be constructed from an R-value. So this is what you want. So you cannot just delete it.
That's the problem with fixing standards. You break legitimate cases sometimes.
But I mean, we cannot delete it currently. When we will need some other constructions in C++ to delete specifically constructing.
So I did show a proposal for fixing some issues with string view, but that definitely won't make it bulletproof. And not even those are sure to make it in C++20. So it's difficult. I think the best way we can deal with it is be aware of the idioms, the correct idioms in using it, restricting ourselves to the safe path. And if we're using the unsafe idioms, for example, like storing them or returning them, properly documenting them with, I don't know, some kind of custom function attributes or whatever, or just function documentation, so that the callers are aware of the chain of references along the way.
Yeah, lifetime management like in Rust comes to mind, for example. Thank you.
Any other questions?
Thank you for the talk. That's, you know, I'm on the committee and I don't always watch what's going on, so it's nice to see it all together. Do you have an opinion, and I'm just interested in your personal opinion, about the string view null issue? Have you watched that?
Do you mean the Z string view proposal?
Yes, so the committee is looking at enabling the constructor with a single, you know, char pointer, whether it would be valid to call that with a null pointer, right?
Yeah.
You know, originally it's not valid.
Yeah.
That's it leads to undefined behavior.
And that's in line with standard string.
Right. But the proposal is to actually make it be equivalent to a string view, an empty string view, if you will.
I don't know if that would help. Maybe in some situations it would make it more intuitive in usage, but I don't have a strong opinion on that. I'm sorry. I don't think it will. I don't know if it will make a real difference. So it's definitely something to think about.
Okay. Thank you.
So if there are not any other questions, thank you. See you later.